All right, guys, here's a short video on how to solve equations dealing with parallel lines that are cut by a transversal. This guy that goes across is our transversal. But when you have parallel lines that are cut by a transversal, you end up with 1, 2, 3, 4, 5, 6, 7, 8 different angles. And we can classify these 8 angles in different ways. The most important way of thinking about them is whether they're big or little. So this guy right here is little. And this guy right here is also going to be little. Now, this one right here is little because these guys are vertical angles, and then this one's also little. So you have 4 little angles. Now we're going to have 4 big angles. So that red one's a big one, this is a big one, this is a big one, and this is a big one. So you have 4 littles and 4 bigs. Now, the reason that's helpful is if you're given something like this, and it tells you that this is 55, you can actually find every single one of those angles, all the 7 other angles. So let's think about this. 55 is little, and so this is little. Those guys are vertical angles. This guy looks little, that's 55. This guy looks little, and 55. Now, what happens when you have a big and a little? A big plus a little is going to add up to 180 degrees. So we're going to do, we'll call this big guy B for big. Big plus little equals 180. And in this case, our little is 55 degrees. So the big plus the little is 180. And then to solve from here, we're just going to subtract 55. We're going to subtract 55. And we find that our big angle is 125. And so now big is 125. This is 125. 125, 125, and 125. So those are all the bigs. So let's do this one on your own. Let's say I draw something like this. Oh, those aren't great. And I cross it like this. Let's say this one right here is 110. Can we find all the others? And yes, we can. 110, that's a big. Let's see, this is vertical angles, so those guys are big, 110. And if they're not big, they're little, and bigs and littles form a linear pair. That's 70, that's 70, that's 70, that's 70. And you can think of these guys adding up to 180. You can also think of those guys adding up to 180. And you can also see that those guys form a straight line, adds up to 180. Okay, so now how are we going to see this with algebra? With algebra, you're going to see questions like this. You're going to see 2x plus 1, and let's do 11. And the first question you ask yourself is this. Is this guy a big or is that guy a little? And those guys are both going to be littles. And the way you check, if you have a sheet of paper, you can put a sheet of paper in there and it doesn't fit into that angle, the edge of a paper. This one, if you put an edge of a paper here, like a 90-degree angle, then you still have room to wiggle it back and forth. So that guy's bigger than 90. This one, you can't fit a 90 in there because it's less than 90. Okay, so those guys are both little. Littles are equal to littles, so we're going to set those guys equal to each other. 2x plus 1 equals 11. And then from here, just regular algebra, minus 1, 2x equals 10. Divide both sides by 2, and you get your answer, x equals 5. Okay, so let's do another type of question you're going to see. Let's say you get something like this, and this one is 2x plus 80. And let's say this one right here is going to be, I don't know, x plus 10. So we have to ask ourselves a question, is this one big or little? This guy is little, and this guy is big. So we have big, and we have little. So big and little, if you have a big and a little, let's write this out. X plus 10, that's our 1, 2x plus 80. Well, we know one is big and one is little, so we're not going to set them equal, right? Because one's big, one's little. Instead, a big and a little add up to 180. So we're going to add them up to equal 180. Okay, now we're going to combine like terms. those x's and x's, they're on the same side of the equal sign. So because these guys are on the same side of the equal sign, we can combine those up. And so combining those up is going to make 3x. The 10 and the 80 add up to 90, and then the 180 just comes down. And then from here, just regular algebra, we're going to subtract 90, and then we get 3x equals 90, we get x is 30, and we're done. We could plug it in and just make sure it kind of makes sense in the question, but that's the whole basic process here. Okay, let's talk about names, because these names are used a lot and they're kind of helpful. So first name we're going to talk about is corresponding. These guys are called corresponding, and the reason why is if I get this line and I move it up, and I move it up, and I move it, try that better, I move it up, and then I move it up, and then I move it up, then as I move up and up and up, then what's going to happen is this angle, that red angle, is going to move up, and its new home is going to be right there. So they're called corresponding because they're in the corresponding position for both of those. So corresponding. All right, so that's the first one, corresponding. Let me just draw these out. So this is corresponding. And there's other pairs of corresponding angles. For example, I could also draw a set of corresponding angles like this. These guys are also corresponding angles because when this line moves up to that line, then those two angles will line up exactly with each other. Okay, so corresponding. Now the other ones are a lot more intuitive the way they're named. These guys are called alternate interior. Now alternate means they alternate sides of the transversal. So this red line is the transversal. And you can tell that this guy and this guy lie on opposite sides or alternate sides of the transversal. And finally, they're called internal or interior because if you imagine this as a kind of tube, then these guys are on the inside of the tube. Both of those blue angles are on the inside of the tube. So they're on the inside of the tube and they are on alternate sides of the transversal. So alternate interior. Okay, now we have these guys, and I bet you can guess the name of these guys. First of all, are these interior or exterior? And you're right, these guys are on the interior. Now, with relation to the transversal, are they on the same side or alternate sides? And they're on the same side. So they're on the same side of this transversal line, but they are both on the internal, the interior of the tube. So we got same side interior. Next one, we've got these guys. These guys are on alternate sides of the transversal line. They're on opposite sides of that red line, and they are exterior. So we have alternate exterior, and these ones are also in the exterior. They're on the outside of this tube. They're on the exterior of the tube, but these ones are on the same side of the transversal line. So these guys are going to be called same side exterior. Okay, so as a really quick review, these guys are corresponding. These guys, alternate interior. These guys are same side interior. These guys are alternate exterior. And finally, these guys are same side exterior. Now, we have some theorems for these. Basically, it's the same thing with little angle and big angle. These guys look like they're both little, and so these guys are congruent. So corresponding angles are congruent. These guys are also congruent. These guys, I've got one little, one big. So one little, one big, because it's one little and one big, these guys are not going to be congruent. These guys are supplementary. That means that the two angles together add up to 180. These guys right here, this is a big, this is a big. These guys are congruent. And these guys, I've got a big and I've got a little. And a big and a little add up to 180. So supplementary. So there you go. Those are the names. Corresponding are congruent. Alternate interior are congruent. Alternate or same side interior are supplementary. Alternate exterior are congruent. And finally, same side supplementary are same side exterior are supplementary. But when in doubt, just think, are they big or little? If they're big and little, they add up to 180. If they're little and little, then they're equal. If they're little and little, they're equal. If they're big and big, they're equal. Okay, that's it.